Sure. Let me get the projector up. We are recording now. Let me get the slideshow set up from current slide. And let's see. All right. Let's start right here. It's a fairly clean slide. Okay. And what's your question? Okay, yeah, but can you give me page number and stuff like that?
Oh, page 277.
277. Okay, I'm close, but not quite there. Okay, page 277. And that, by the way, is 4.2 exercise. And which one?
It's numbers 9 through 12.
Okay, pick one.
Number
10.
10.
Okay, why not 10? All right. This says, finding a point on the unit circle. In these exercises, find the point xy on the unit circle that corresponds to the real number t. And number 10, the real number t is equal to pi force. Okay? Now, you need to find on the unit circle, so not a bad idea to draw a unit circle, or as close to semblance as you can. And we'll do this as 1, 1, minus 1, minus 1. So this point right over here, give me this point right here on the unit circle. It's not the one we're looking for, but give me what that one is. Point right over there. What point is that? Point right there. Big ugly blob. What is that? 1, 0. Perfect. Up here, this one will be 0, 1. Okay, this one over here will be negative 1, 0. And this one down here will be 0, negative 1. Okay, got the idea. Now, you want the point xy on the unit circle corresponding to real number t. T is equal to pi force. Now, you have a clue of where that is approximately. Where? First quadrant. And how would you describe where in the first quadrant? Second? Okay. It exactly bisects the first quadrant, right? Exactly bisects it, because the first quadrant, that's the 90 degree, a pi halves angle, right? So this is exactly half of that. So that is actually the line y equal x, the identity function, remember? Okay, so what we want is the xy point that is identified by where that intersects here. Now, if that's something you remember, we can write it down. If not, we can figure it out.
So those points where it's square root of 2 over 2.
You got it. It's square root of 2 over 2, square root of 2 over 2.
Is that
The
the real number?
real number is pi force, t equal pi force. And the xy, the coordinates for that point, on the unit circle will be square root of 2 over 2. Square root of 2 over 2. Okay? And what?
I think the question was, like on the test.
Okay. Let me find the test. I don't have it on top right here, but. Okay, wait just a second. I'm getting closer. I'm almost there. Nope, not there yet. I'm so close. There where I am. Okay. All right. Which one are you talking about? Number 7. Find the point xy on the unit circle that corresponds to the real number t is equal to pi fifths. Okay.
That's what I could find.
Okay. Pi fifths. Okay. Now, I think what it's requiring you to do here, see, all these are the ones we're familiar with, right?
Right.
Okay. Okay.
It would be between 4 and 6.
What's that?
It would be between pi 4 and pi 6 in the first quadrant, right?
Okay. Let me find it again. Yeah. Pi fifths is between pi fourths and pi sixths. You're absolutely right. Okay. Now, when we were doing this, we hadn't actually introduced, in fact, now that I think about it, let's move on. I think you're staying in 4.1. That was 4.2. Yeah, okay. But when you're evaluating the sines and cosines, let me, yeah. Look on page 273. See that block? Definitions of trig functions. Okay. What you're looking for is xy for any given t. Do those first two entries. Where it says let t be a real number, let xy be a point on the unit circle corresponding to t. Then look at that. To get the x value, you do. Yes, don't give anybody else the answer, okay? And to get the y value, you do the. Right. That give it to you?
Yeah.
Okay, good deal. Any others? All right, good deal. And you'll find out when you do that that it is in between those other two that you were just talking about. Okay. Anyone here did not get the first test? I think y'all are all been here. As people who haven't been here don't have it. All right, any other questions before we get started on what we're going to do today? Okay, so let's move along. I had where we left off last time. It's the thing that says, here's where we were. All right, if no questions, we're in 4.5, graphs of sine and cosine functions. And we had just talked about these two, there being the sine function, there being the cosine function. We talked about the period, the one complete cycle before it starts repeating itself, like you see that it does. So it says here, note that in those two figures, figure 436 and 437 that we just showed, that the sine curve is symmetric. Okay, let's go back and show it. Sine curve is symmetric with respect to what? No, not the y-axis. See, that's different. That's what? Not the x-axis either. What's it respect to? The what? Origin, exactly. It reflects across the origin. Okay? You may have said it. I can't hear it. Bottom of page 299, and Philandria? Okay. Just came in. Didn't see you come in, sorry. Oh, we got somebody, yeah, Kamari. I did see him come in, but I forgot to mark him. Okay, good deal. Just got, I think, 5 more to go, so half the class is here. Glad y'all are here. Where's the other half? Okay. So the sine function reflects across the graph reflects across the origin. How about the cosine function? How about the cosine function? Give it a shot. cosine function reflects across what? The y-axis, yeah. You see what's over here? Same thing's over here. That folds right on itself. This one folds this way to reproduce itself. Okay? So the cosine function, so that makes the sine function what kind of function? As in even or odd or neither? Okay, wrong, but okay, good guess. Most functions are neither, but not sines and cosines. In fact, most trig functions are either one or the other. It's an odd function because alpha minus x is the opposite of alpha of x. So what would cosine function be? Even, because alpha minus x is the same as alpha of x. Okay? So that's an even function because it reflects across the y-axis. And sine's odd because it reflects across the origin. So, the sine curve is symmetric about the origin. Cosine curve is symmetric about the y-axis. These properties of symmetry follow from the fact that the sine function is odd. It's an oddball, you know, and the cosine function is even-handed. Okay. Even. Okay? Make sense? Now, to sketch the graphs of the basic sine and cosine functions by hand, which is always a lot of fun, it's helpful to note 5 key points in one period of each graph. This is for sine and cosine. They're really 4, but you repeat 1, making it 5. Okay? These are the intercepts. Now, what kind of intercepts do we have? Basically, 2 intercepts. Axis and y-intercepts. How many y-intercepts are you typically going to have? 1 and only 1, because if you intersect the y-axis twice or more, it would be a function, wouldn't it? Okay? Can only, because that's a vertical line. But you can have bagoodles of x-intercepts, but we're only going to do one site. So we're going to do those. We're going to identify the intercepts. The 1 y-intercept and maybe a couple or so x-intercepts. We're also going to identify the maximum points and the minimum points. And here's what they are typically for a sine or a cosine curve. I'll start with the sine over here. Where does the sine start? Typically, when x equals 0, what sign? Sine of 0 is? Go back and do the first 3 sections over, 4 sections over again, okay? Sine is 0, because it's the y value, right? What you just did, remember? Sine of t is equal to the y value, right? That's what you looked up and found. The y value over here is that's 1, 0, so that sine is 0. So sine starts at 0, usually goes up after that to 1, down to 0, down to minus 1, and back up to 0 again. There's your 5 points. The 1 and only 1 y-intercept is going to be at 0, 0, which makes it also an x-intercept. It's not the only x-intercept because it intersects again at pi 0. That's when you go halfway around, your y is 0 again. And when you make all the way back around, you're at 0 again. So sure enough, you have 3 x-intercepts. Now really, that's a repeat of this one. But that's why we have the 5th point. We repeat the first and the last. In one period, it's going to come back right where it started. Okay, so there's your 1 y-intercept, 3 x-intercepts, this one being the same. 1 y-intercept and an x-intercept. The maximum is usually going to be for y is equal to sine x, the basic sine function, when x is at pi halves, your y is at 1. Okay? That's going to be as high as it ever gets, so that's going to be your maximum. Then it goes back to 0, and then it goes down to minus 1, that's your minimum. Okay? And then it goes back. Well, what have we just done here? When it goes back to the same position it had before, going the same direction it was going before, we just completed one period. Okay, so what we do, we take the period, divide by 4. That's what you do. Here's your starting point, 1/4, 1/2, 3/4, and the full. The starting and the full, they have to be the same point. So we're going to do that from now on. Even when it's not just sine x. When we start introducing other things in here to mess it up, we're still going to take those 4 points. Really 5 points, but we divide the period by 4. So the first thing we're going to do is determine the period. What's the normal period of this? How far it goes before it repeats itself? Yeah, which is? How much of a circle is that? One complete circle? There's 2 ways to measure angles in a circle. Say again? What are the 2 ways to measure angles around the circle? Degrees and radians. So give it to me in either one. I don't care. 360 degrees or 2 pi radians. Very good. So 2 pi is normally your period. Now, if you have anything else in here, that's going to change your period, but we can still figure it. So let's go to cosine now. Okay? What's this? Where does cosine begin? At 1, exactly. So that's this y-intercept. One and only y-intercept is at 0, 1. Okay? Now we know it's going to be back there after 1 complete period. It's got to be back there at the same place. So 2 pi 1 for this function, that's going to be it. So we got 2 of them already. Now, halfway between the beginning point and 1 period later, which is at the same point, these are, by the way, your maximum. So halfway between that is going to be your minimum. That's going to be at -1. And halfway between the maximum and minimum, you're going to have a 0. Halfway between minimum and maximum, you're going to have a 0. You can do that every time with a sine and cosine function. Identify those things. Like halfway between these 2 zeros is another 0. Halfway between these 2 is the maximum. Halfway between those 2 is the minimum. Okay? Those are going to make it so easy to plot these points. So get that down. Get used to how this looks, how it goes. So I think we're ready for example 1. Sketch the graph of y is equal to 2 sine x on the interval minus pi to 4 pi. So I'm going to put my vertical axis there. I'm going to put my horizontal axis here. Okay? I need to go, okay, let's just say this is 4 pi. Okay? Halfway between that will be 2 pi. Halfway between that will be a pi. Halfway between that will be a pi. And that same distance over here will be a negative pi. So that's where they want us to plot these. Okay, I don't have it exact, but close. Okay. Y is equal to 2 times the sine of x. Okay. I sort of don't like this too much because we're introducing something we haven't done yet. We're going to do it really soon. What does that 2 do for us here? Remember back in. Second? It does what? Okay. It doesn't really change where it starts, but it changes where it's going. Because sine starts where? 0. And when you multiply 2 times 0, you have to change it. So let's get that. Sine of 0 is 0. We got that one done. What does that 2 do for you? Where does sine usually go to? That's what I'm getting at. Always between -1 and 1. Sine is that, just the sine, between -1 and 1. So what happens when you multiply by 2? Now you're going from -2 to 2. So this expands your range. Okay, so we'll do a 2 up here, 1 here, -1 here, and a -2 here. So it's going to expand the range. Okay? And we already got where sine started. What is the normal period of sine x? period of sine x. Oh man, you all just answered that not long ago. Okay. Wait. Yes, 2 pi. Very good. Jasmine's here. Okay. Okay. So 2 pi. What does that tell you about 2 pi? Where will you be then? If that's your period, you're going to be at 0 again. Okay? Remember how a sine function looks? Most of the time it goes up and then down and then back, and that's where it starts. So halfway between these two zeros, what do we normally have? Not yet. One period goes through the whole cycle, going up and down. So halfway between those two zeros is? At pi, yeah, I got that. And what will the value be there? Sine of pi is? Huh? I can't hear. Okay, well then. Okay. Okay. Well, think of this. What did we say the sine was? Pi is an angle. The sine is anywhere. Sine of t is going to be your. You just looked it up. Now we're talking the unit circle, but it still works. Sine of pi is 0. Exactly. Because you're halfway around. Pi is halfway around, and your y value is still 0. It's 0 here, it's 0 here. So halfway in between, and by the way, the 2 pi is when you get back here again, so it's 0 again there. It's the y value, okay? So here's the 2 zeros, that means you got a 0 in between. All right, so now all we got is a bunch of zeros. Feel like this?
Why do you have pi on there twice?
Do I? Oh, sorry. Yeah, sorry about that. I have it on there 5 times. It's just that I have numbers in front of some of them. Okay, never mind. Okay. No, I'm not sorry. No, never mind. Okay. Okay. So we got 3 zeros so far. All right. Where do we go from here? What you got halfway between these 2 zeros? 2. Yes, you got your maximum, which is 2. So at pi halves, you have a 2. Halfway between these 2 zeros? Negative 2. You got your minimum at negative 2. Okay, so this will be at 3 halves pi. Pretty exciting stuff, isn't it? Okay. Now, where do we go from there? Notice, from here, it's a periodic function, so it's going to follow the same pattern. 0 at 0, 0 at pi, 0 at 2 pi, 0 at 3 pi, 0 at 4 pi, 0 at negative pi. Every pi, whole number pi, is a 0. So fill in the blanks. Okay, we got those. Since it's going down here, where it's going to be at 5 halves pi. Where will it be then? At what? Hey. Good, thanks. My time or the class time? Okay, sure. Okay, do I need to leave recording on? You want that on? So people at home can hear it? Yeah, I'm recording. You don't want it on? Well, this is so people at home can hear it too.
Oh, yeah.
Okay, well then come up here so you can speak into the thing.
All right. So I'm over here.
Yeah, just
Okay.
near the computer there.
All right. All right. So how's everyone today? Hey, how y'all doing? Okay, so I'm gonna take it go quick so you can get back to your class because I know you're itching to get back to your lesson. First thing is first. Today we have an event going on at 1 o'clock in the rec room. the Bessemer Rec Room. These are the flyers for it. They're everywhere. Just letting you know which ones to look at. It's called the locker room. Sorry, ladies, it's just for the guys. I won't even be there. It's just for guys. You can get it. Come talk about guy stuff. Whatever y'all talk about, that's what y'all will be talking about. We have another one for the ladies next month. So for all the guys, please spread the word. Y'all are more than welcome to go. It's at 1 o'clock in the rec room. Second thing is we have homecoming coming up in 2 weeks, the 20th through the 24th. And you'll see flyers soon, but a couple of the events that I would like to bring to your attention is the Choice Awards. And with the Choice Awards, we're in the process of nominating currently right now. So these are what the flyers look like. The categories are on here. You're nominating students. Actually, you nominate best dressed, cutest couple, best male athlete, best female athlete, most school spirit, best dancer, most talented, best advisor, best teacher, most involved, and best overall. So these are everywhere. So you see these, they'll tell you how to nominate. You nominate online, so you don't have to go to anywhere in particular. Just take out your phones, send your nominations. Nominations close on Friday. You will vote on Monday. You can be in Africa and do it because it's online. So
is that this coming Friday? Is that
yes,
tomorrow?
yes, sir.
Tomorrow.
Tomorrow's your last day to nominate anybody, and you vote on Monday. Last announcement is talent search. On Monday, on the 20th, we will have a talent show for homecoming week. Blue and Gold Talent Search. However, if you are interested in participating, please sign up with me via email, which my information is on here, so that you can audition. And auditions are on next Wednesday, the 15th. Now, this is not a pass or fail audition. This is just an audition to make sure that I will still have a job the next day after the talent show, because you didn't come in bringing crazy music and stuff. So I just need to make sure everything is good. So just sign up to come audition with me. Bring your music and everything that that you will have for that. And that's pretty much all I have. Any questions?
Where are the auditions?
Auditions will be in the rec room.
On the second floor.
Yes, it's room 175. It's right across from the faculty lounge.
Okay, yeah, on this campus.
Yes, sir.
Okay, right.
And on this campus, we will be auditioning. Oh, I told everybody the wrong time. From 11 to 2. So from 11 to 2, you can pick a time anywhere between that. Shouldn't take more than about 10, 15 minutes. Pick a time with me and come in and audition. Yep. Any other questions? Thank y'all so much. Thank you so much. Sorry for taking up your class time.
No problem. All right, good deal.
Will there be food at the school's locker?
What's that? Okay. I probably shouldn't say this on here, but remember, yeah, you know what I'm thinking. We don't have that kind of talk in the locker room.
Right.
Not in our locker rooms. I don't know. Never mind. Never mind. I didn't say that, did I? All right, back to Trig. Okay.
Hold up, time out. Time out.
Back during the campaign, someone was caught on tape with all sorts of things, and he said this is just locker room talk. We don't talk that way in the locker room. At least I played football, basketball, ran track, intramurals. We never talk any of that kind of stuff in the locker room. So we're not having that kind of locker room talk. Okay. You're not that high up. Okay, never mind. We won't go there. Okay. Some people are informed and some people are not so. Okay, never mind. Okay, where do we go from here? I reported all that. All right. Yeah, how about 5 has popped? We've got the first period down. What's it going to do after that? What will it do after that? Okay, yeah, no, the next one would be 7/5 pi, but I'm saying what's the y going to be there? That was all I was going to ask. 7/2 pi. And this one will be negative pi halves. Okay, this is pi halves. Okay. I want the y values. What's the function? I'll draw in that first period. Okay. Where does it go after that? Positive 2 again. And then at 7/2 pi, negative 2, another minimum. At negative 1/2 pi, negative 1/2 pi, negative 2 again, then up to here. So here is the graph. What it asked us to do was sketch the graph of the function between negative pi and 4 pi. There you have it. Okay? Again, identify in one period your key points. Where it begins and ends, got to be the same. For sine, that's going to be zeros. And between that is a 0. And between the first two zeros, a maximum, in this case a +2, and between the next two zeros, a minimum. And then it repeats. Between the next two zeros, a max, between the next two zeros, a min. Get your zeros on there, and then get your others. Now, this is not drawn very well here, because remember, sine functions are always smooth and continuous. So don't have them pointed like that, okay? Smooth and continuous, there it is. Don't have them jagged, zigzag. Make sure it's smooth and continuous. Make sense? All right. Yeah, never mind. Get off of that. All right. But when I saw that, I thought, that is not the title to give this thing. But anyway, never mind.
So this would, you just supposed to actually draw that from negative pi to 4 pi.
Okay, yeah, it told me to do that, so I got my thing big enough to get all that on there, spread them out, even them out, got my pi's on there, and then had y'all identify for me that every pi was a 0. It took like pulling teeth to get you to say it. You finally got there, so every pi. So then I needed, that's not going to show me what the graph looks like until I get some other points. We'll go halfway between the zeros, and that's going to be at pi halves, 3 halves pi, 5 halves pi, 7 halves pi, and even back here at negative pi halves. Okay? So that's going to be your other points, and that's going to be your max or min. Starting with max, going to min, max, min, going from max to min. You have those, then connect the dots.
So is it necessary to find those halves?
Yeah, just so you'll know where to put the max and min, yeah. Okay? All right. You do that, get one period done, then split up the period. Divide the period by 4. No matter what that period is. This happened to be 2 pi. Divide 2 pi. That's where we started. The period was 2 pi. And take the 2 pi, divide it by 4, and that's going to be pi halves. So we're going to do every half pi. Yeah, that's why we had to do half pi's. Okay? Now that's how we did it. You want to see how they did it? I'm sure the picture won't be quite as pretty, but maybe it'll be close. Okay, note that y is equal to 2 sine x. Well, they already wrote that, so I'm glad they noted it again. Good for them, using space wisely. Okay. Now, what that means is 2 times the sine of x. Indicates the y values for the key points will have twice the magnitude of those for y is equal to sine x. Yes, y'all picked up on that right off the top. Okay? With probably fewer words than they did. Okay. So, divide the period into 4 equal parts. First, identify the period, 2 pi. It took pulling teeth to get you to do that, but you finally got the period was 2 pi. Divide it into 4 equal parts, which we did. That would be 2 pi divided by 4 is pi halves. So the first, we'll do the x's first. 0, pi halves, pi, 3 halves, pi, and 2 pi. You're doing each, splitting that period into 4 equal pieces. Starting here, 1 piece, 2 piece, 3 piece, 4 piece. So however you want to do it. Okay? Noting that this one and that one are going to have the same y values. And since it's a sine, those happen to be zeros. Well, halfway between the ends of the periods, you have another place at 0 for a sign. So put that one in. And halfway between the first two zeros is your first maximum, and halfway between the next two is the first minimum. And then after that, just keep going. Intercept, maximum, intercept, minimum, intercept. Okay? Identify the x's first, and then identify what y's go with those x's. Does that make sense? It's pretty straightforward. It's the beauty of trigonometry. Everything repeats itself. These are periodic functions. Once you get the hang, it's pretty good. Okay? Now, by connecting those key points with a smooth curve and extending the curve in both directions below the over the interval, you get the graph shown. So what we did, we took this one, a 0 here and a 0 there. This is 0 and 2 pi. Halfway between was a 0. Halfway between there was your max, which is a +2. Halfway between here was a min, which is a -2. And then keep extending this halfway between. Okay, stop. You see that every pi has a 0. 0, 1 pi, 2 pi, 3 pi, 4 pi. 0, negative pi, negative 2 pi. Okay, every pi. It's going to keep this. That's the pattern. It's the period. You know, that's going to happen over and over again. So you got those zeros, then put your half pi's in here, which is what we did. And between these two, that's going to be a max, min. That's got to be a max. That's got to be a min. This is a max, so this is a min. So you've got all your points in there. Draw nice, smooth curves between the points. Make sense? All right, good deal. Oh, well, I meant to ask that lady. I know I've seen her before, but I can't remember her name. Does anyone know her name? Huh? Okay, I'm the same way. Okay. Second? The lady who was here? I don't. I know she's a student support coordinator, but I cannot remember her name.
You didn't even see her.
What's that?
She came in here behind you. She left her phone here. You didn't even see her. I thought it was funny. You were up there on the point of the board, and she came in here, got her phone on the desk, and went out. You never even saw her.
She came. Oh, she did. Well, after she left. Oh, okay. I had a phone. I didn't know it.
Like
Okay.
2 minutes ago.
Okay.
Miss Burke.
Huh? Miss Burton? Okay. Wow, we have a Mr. Burton who teaches English. I don't guess there are any kin. Okay. All right. That was example 1. Now, I wish they had done this first. We're going to talk about 2 features about sine and cosine functions. The first of these is amplitude. The second is period. Guess what? We've been talking about the period, haven't we? Well, we haven't mentioned the word amplitude before, I don't think. What is amplitude? What would that be? Period is how you go on the horizontal axis. Okay, that's where you put that. So amplitude would be where you go on the vertical axis. What was our amplitude of that last one we just did? 2. Normally, the amplitude is 1, unless you have a number in front of it. Normally, your period is just for talking about it, split it into 4 pieces. What was that normal period was? One time around the circle, 2 pi, very good. Okay. Unless you got something written in front, another coefficient in there. So that's what we're going to be dealing with. The rest of this section, we'll study the graphic effect of each of the constants, A, B, C, and D, in this equation. Why they write it this way, I'm not absolutely sure. It seems like to me they should write this A cosine, I don't really like B minus C the way they do it, Bx minus C plus D. Why didn't they put the plus D down here? So A, B, C, D. So they put the plus D in front. Well, that's the last thing we're going to talk about. But we're going to do it. And then we'll also do Y is equal to D plus, or plus D. A cosine Bx minus C. I'll do a plus D down here. And we'll talk about what each one of these does. Now, I want to have you do a flashback. that fun course you had right before this one, Math 112. And it was fun, wasn't it, Kamari? Yes, you got it. Okay. All right. So flashback to there. What did we call these things you added or subtracted to either the function value or to the x value? What did we call those? The what? What did that produce? When you added or subtracted something from the functional value. Say again? Okay, well, they were called either, if it was to the function value, there were shifts. You shifted it up or shifted it down, or you shifted it right or shifted it left. These were the things you added or subtracted to your functions. You remember that? You thought you were supposed to forget because you finished 112, right? Don't have to remember that anymore, right? No. Okay. Now, what happened when you multiplied things by either the x or the function? What did that produce? Stretches or shrinks, exactly. These were called your rigid transformations. These were called your non-rigid transformations. Don't you remember that? Okay. So, that's what we're going to be doing. And frankly, when we had that 2 sine x, what were we doing? Stretching vertically. That's what we just did on that last problem. In fact, the book did it, we didn't. They showed the basic sine curve. Then when you put the 2 there, you stretch vertically. But we multiplied by a number greater than 1. Multiplied the function by that. The function is the y value. So that was a vertical stretch. Okay. Now, I just sort of gave that away. And that last problem, which one of those letters did we adjust? And we had y is equal to the A. And that was a vertical stretch. Guess what we're going to call that? Our amplitude. Now, what we haven't done yet, but what the period depended on was the thing that came in front of the x. If there's a 1 there, then it was 2 pi. If it's anything other than 1, you either got a horizontal stretch or a shrink. We'll get there. These numbers have to do with horizontal shift, vertical shifts. So we're getting way ahead of ourselves. Let's start with this first one. Just the A. Forget the D, forget the B, forget the C, minus C, just A sine x. The constant A in y is equal to A sine x, just like that 2 was before. As a scaling factor, a vertical stretch or a vertical shrink. When will it become a vertical shrink? When the A is, say it again? Okay, you're getting close, okay. When A is greater than 1, it's a vertical stretch, and when A is between 0 and 1, it's a vertical shrink, okay? Now, what happens if A is negative? Remember what that did? Back in 112? That's when you reflect it across the x-axis. So what that would do, if you were going like this, and you negated it, would go like that. Okay. So that was that. So they're talking about the absolute value of A. Forget about what sign it is. The absolute value of A, if it's greater than 1, you have a vertical stretch, and the basic sine curve is stretched vertically. When the absolute value of A is less than 1, meaning basically between 0 and 1, then because absolute value won't ever be negative, then you have a vertical shrink. Okay? Or vertical skunk. No, it's shrunk. Never mind. Okay. So the result is that the graph of y is equal to A sine x ranges between minus A and plus A rather than between minus 1 and 1. We did that before. I asked you, what does sine range between? Minus 1 and 1. You multiply by A, That's going, if A is a small number, it might be minus 1/2 to 1/2. Big number, minus 2 to 2. Whatever. That's the A, it goes between plus or minus A. The absolute value of A is what we call the amplitude. Okay? How high or low does it go, above or below the equilibrium? Okay. So that's what we get. The range of the function is now for A greater than 0 is minus A to A. Any A greater than 0. Well, yeah. And if A was less than 0, it would still be minus A to A, but it would just be in reverse order. Minus A to 0. If A is a negative number, then this would be the positive, that would be. Yeah, you'd have to have the A itself over here. Okay, never mind. So the definition of amplitude of sine and cosine curves, both of these curves, the amplitude of y is equal to A sine theta and y is equal to A cosine theta represents half the distance between the maximum and minimum. Half between that is what I call the equilibrium position. So it goes up or down from there. So it's half the difference between the maximum and minimum values. Okay? And we say its amplitude is absolute value, whatever the coefficient of the function is. The thing multiplied by the function, absolute value of that is your amplitude. All right. Now, I already hinted at this. What happens if you have a minus in front of it and you answer it? It's reflected across the x-axis. Okay? So if you have y is equal to 3 cosine x, where does cosine x usually begin? Cosine x begins at? Just cosine x. Plus 1. You're right. Plus 1. So therefore, where would this one begin? Negative 3. Because that's a plus 1, negative 3. So rather, and that one would begin at plus 3. And you put the minus, and it flips it down here to minus. So normally the cosine would begin here. If it's a minus 3, then the minus flips it over, and the 3 stretches it by 3. So either way you want to look at it. Second? Yeah. Y is equal to 3 cosine x would be stretched up to here. Y is equal to negative 3 cosine x would be flipped and stretched down to here. So basically, think, what is cosine of 0? Normally 1 multiplied minus 3 by minus 1. Gets you started. Now, from there, what's the period of this, cosine x? Period. Say again?
I see it one.
Period. Say again? 2 pi, exactly. That's normally the period of a sine or a cosine function is 2 pi. So that means whatever it is at 0, which is minus 3 we just determined, 2 pi later, it's going to be at minus 3 again. Okay? Halfway in between those two, at pi, it's going to be at plus 3. Halfway between that, it's going to be at 0. Halfway between these two, it's going to be at 0. So there's your function. Okay? And then you can extend it in both directions. Okay. Does that make sense? Good deal. Because y is equal to A sine theta completes one cycle between 0 and 2 pi, what do we call that? Completes one cycle, we call it a period. Okay, completes one period between that. It follows that y is equal to A sine bx. Uh-oh, now we've introduced a constant here. Now we didn't have a... Okay. Sorry about this, folks. They skipped example 2, didn't they? So I think what we need to do is go back and do example 2. Let's do it here. Example 2. On the same coordinate plane, sketch the graph of each function. Okay? The first one's going to be, actually I'm going to do the first one, y is equal to cosine x. That's going to be an easy one. Now, give me a color. red, is that what you said? Okay, we'll do red, and we'll then do y is equal to 1/2 cosine x. And give me another color. Second? Green. Light or dark? Dark, okay. Y is equal to 3 cosine x. So we're going, we're going to plot all three of those, okay? Guess I'll do it. Just messy, isn't it? And they didn't tell us a range over which to do. Okay, so we'll just do. Oh, let's go back to black or dark. Okay, I'll do it down here just so we can see. All right. Now I know ultimately the biggest amplitude I'm going to have is plus or minus 3. So let's do 1, 2, 3, 1, 2, 3. Sort of, okay? Now, we don't have to do more than one period, but let's do maybe a little more than one. So let's have this out here making one period. What is one period for cosine? 2 pi. So let this be 2 pi. Half of that is pi, but we're dividing into quarters, so that's going to be pi halves and 3/2 pi. And since we did it on that side, let's do the same thing over here. Make this minus 2 pi, make this minus pi, make this minus pi halves, and make this minus 3/2 pi. I may not have done it evenly, but you get the general idea. Now, let's do the basic function. Where does it, I'll label this 1, 2, 3, -1, -2, -3. Okay? Let's plot that first. Where does cosine begin? 1. 0, 1. Okay, there's that one. Okay, what's one period? 2 pi, so it's got to be back at 1 at 2 pi. And 1 at -2 pi, because that's one period later too. And what's halfway in between, and those, by the way, are your maximum values. Cosine starts at its max, so what's exactly in between 0 and 2 pi is pi, but what's it going to be there? -1, okay? That's its minimum. And what's halfway between the max and the min? 0. Halfway between the min and the max? 0. Halfway, okay. We got our two maxes here, so halfway between those has to be another min, down here at -1. Halfway between these two is a 0. Halfway between those two is a 0. You got all your points there. You just draw your curve. There it is. That's not one they asked for, though. What's the first one they asked for? In red. Ah, finally. What's the difference between that dark blue curve I just did and the red? Only difference is? And what is it? What's that half represent? Second? Amplitude. And that means the maximum or minimum value is going to go. So this time it's going to go from +1/2 down to -1/2, up to +1/2, down to -1/2. That's as far as it can go. That's its amplitude. Okay? The zeros are going to be the same, because 1/2 of 0 is 0. You're not changing those any. So this curve, the red curve, graphs like this. Got it? Not that bad, was it? Okay? What about that green curve? What's going on there? Amplitude is 3. So now where is it starting? Up at plus 3. It still goes through 0 because 3 times 0 is still 0. But now 3 times minus 1 is minus 3. 0 plus 3. 0 minus 3. 0 plus 3. Now your curve goes like this. Still has to pass through the zeros and through the maxes and through the mins and keeps on trucking. Make sense? The red curve is a vertical shrink. The green curve is a vertical stretch. Your parent function, you might say, is that blue curve that we started. Does that make sense? Good deal. That was example 2. Seemed like I was having to pull teeth with that, so you might want to do a checkpoint when you, as soon as you get home or wherever you're going next, library or spare classroom, wherever. Okay? Now. Yes, sir. Okay. Yeah. All right. Okay. Then we were supposed to hit the reflection thing. I got a little ahead. I didn't realize they skipped the thing. So now let's talk. We got reflection. When you have a minus sign, what that does, flips it across the x-axis. Now let's get to your period. We did amplitude, now we're on period. The period, the amplitude was when you have something multiplied by your function. Vertical stretch or shrink. But this one, since it's just sine x, you know sine x always goes between 0 and 2 pi, so you call that one complete cycle or one period. But when you introduce a variable here, a b for the x, not for the function itself, but for the x, now you're either doing a horizontal shrink or stretch, because you're multiplying the x, the horizontal variable, by a constant. Okay? And since this one, the period is 0 to 2 pi, now that means bx goes between 0 and 2 pi. Right? But if bx goes between 0 and 2 pi, let me phrase it this way. Let me get back to dark. Okay. If in a normal sine or cosine function, you have 0 to 2 pi, okay, x is going from 0 to 2 pi. That's your one period, right? When you put a b in here, you get 0 is less than bx is less than 2 pi. Because now what the argument is bx, okay? To get what x is going from, you divide by b. Okay? So now the period of your x is now going from 0, that's still 0, to 2 pi over b. So when you have a b in there, your period, now b's are always positive, by the way. You never multiply the x by a negative number. That is trying to do a flip across the y-axis, and that just gets really awkward. So leave that b always positive. Now what you have is your new period is now 2 pi over b. Going from 0 to 2 pi over b. So the period of a sine and cosine function, if this coefficient is 1, it's 2 pi. If it's anything other than 1, b times x, then it's 2 pi divided by b. The period of y is equal to a sine bx, and y is equal to a cosine bx. The amplitude, absolute value of a, the period is 2 pi divided by b. Remember that. That's where we start. Once we have the period, we split that into 4 pieces, and then we go from there. So notice that when b is anything between 0 and 1, in other words, it's a small number, less than 1, if you divide by a small number, that makes your period a larger number, something bigger than 2 pi. But if your b is a larger number, and by the way, that would be a stretch then, but if your b is a large number, dividing by a large number actually makes the period smaller, so that's a shrink. But remember back when we were doing translations of functions, okay? Remember, whatever you did to x always seemed backwards. Remember that? It does with shrinking and stretching. If you got a big B, it's a shrink. A big small b is a stretch. Big A is a stretch, and small a is a shrink, because you're doing the function by that. But when you're doing the period, the x, by that, it goes in the opposite direction. Sorry about that. The x's are always backwards. Okay. All right. Enough of that. Similarly, when b is greater than 1, in other words, multiplying by a larger factor, then the period of y is equal to a sine bx is now less than 2 pi, because you're taking 2 pi, dividing it by b, which is greater than 1, and you make a smaller number. Okay, so that's a horizontal shrinking of the graph. When b is negative, okay, you're reflecting across the axes, and then you just have to do the sine of a negative x is minus sine of x. So that's the same as reflecting across the y-axis, but cosine of negative x, because it's even, is the same as cosine of x, don't change a thing. So that's why we usually don't let b be negative. We keep b positive. Okay? So here's example 3. Sketch the graph of this. Now, do you want to start with the parent function? Okay, let's start with y is equal to sine x. Okay? We'll do that one first because we like it, right? Okay. All right. Now, I'm going to cheat a little bit. I'm going to start this one out here at 4 pi. I'll put this at 2 pi. I'll put this at pi. This at 3 pi. I got the 3 in there this time. Okay. Minus 4 pi. Minus 2 pi. Minus pi. And minus 3 pi. Okay. What kind of y-axis do I need here? What are we going from and to on the y-axis? Second?
0 to start at 0.
Second?
Start at 0.
For sine, yeah, we'll be starting at 0. But what are the max and min I need to put on my y-axis? Plus or minus 1, exactly. There's the amplitude is 1. The coefficient's 1. If you don't see a coefficient, you understand it be 1. So this is going from minus 1 to 1. Okay. Now my scale isn't right, but live with it. Okay. Now, we're going to start with sine x. What's the period for sine x? 2 pi. So you're going to have a 0 there, a 0 there, a 0 there, a 0 there, and a 0 there. But what's in between your those zeros? Another 0. Remember, your period goes up and down, so you got to have an in between 0. Okay? So every pi you got it. Now this is your basic function. That's this one. Right here is what we're graphing. And what's in between your first two? Pi halves, 3 halves pi, 5 halves pi, 7 halves pi, negative pi halves, negative 3 halves pi, Negative 5 has pi. Negative 7 has pi. It's sort of messy, but you can live with it. Okay? What's in between your zeros? Plus or minus 1. Which goes first? Plus 1, minus 1. Plus 1, minus 1. Oops, wrong place. Oops, boop, 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 boop. Back up. Okay, minus 1. Over here, minus 1, plus 1, minus 1, plus 1. Okay? So basically this is what that sine function looks like. If I could be fairly regular here. Not very. Ooh, some of those way too pointed. Get over it. Okay. What's different about, and what color you want the y is equal to sine pi over 2? Pick a color. Purple. Okay. Now, what do we do with that? What's the first thing you need to decide about this one? Okay. Okay. In fact, from now on, this is where we're usually going to begin. Okay. First thing you do is do your period. What's the period of this function? I'm sorry, amplitude. Let's start with the amplitude. What's the amplitude of that? Second? 1. Okay. So we're going to have the same amplitude we did on this one. Now, what's the period of this one? Let's rewrite this ever so slightly as sine of 1/2 x. That's the same thing as x over 2, right? Okay. So what's your b there? 1/2. And what's your period? Period is, what's the normal period? 2 pi, but now, since you got a b, it's divided by b, so that'll be 2 pi divided by, what's your b? 1/2, which is the same as multiplying numerator and denominator by 2 to wipe out your denominator there, right? And that gives you 4 pi. Your period is 4 pi now. That's why I drew it to 4 pi. So you're going one period from 0 to 4 pi. And what's halfway, and by the way, your zeros there. This is a sine function. What's halfway in between those two zeros? Sine function. Another 0. But what's halfway between your first two zeros? Your maximum, your plus amplitude, which is 1. Then you have a negative 1. Going the other way, you have a 0 here and at negative 4 pi. The midpoint 0 is there, and then halfway between there, you have a minus 1 down here and a plus 1. Where is it? Right there. Up here. These got sort of scrunched. So this new function is this. Whoops, I lost it. That. So what we have here, the purple is a horizontal stretch because your coefficient was less than 1. So a horizontal stretch of your parent function. Does that make sense? And it stretched it double. Everything was double. Okay? This point here was at pi it has, is now at pi. This point, we didn't have, this point here was there at 5/4, 5 has pi, it would be the next time at 5 pi. This point here was at 3 has pi, double that, and you're at 3 pi. So it's a horizontal stretch. This 0 was doubled to 0. This one was at 2 pi. This one was at pi. It stretched to 2 pi. This one's at 2 pi. It stretched to 4 pi. So everything is a stretch by 2, 1 over 1/2 by 2. Okay. Does that make sense? All right. Let's see how they did it. Let me is it? It can't be. Oh my, it is. Okay, let's erase this. Just quickly see how they did it. Amplitude is 1, first thing to determine. Next is the period. The period is always 2 pi over b. Remember that. 2 pi over 1/2, that would be 4 pi. You got that? And now your values of b, split that 0 to 4 pi into 4 equal parts. 0, 1 pi, 2 pi, 3 pi, 4 pi. Okay, there's your 5 points. And the first one's the intercept, the x and y intercept. At the end is going to be an intercept. In between is going to be an intercept. And then in between the first two zeros, you got a maximum at 1. And in between the next two, you got a minimum at -1. So that's how it looks. There's the parent function, y is equal to sine x. And then you do a horizontal stretch at by 2. And this is your u function. They did not quite as far as what I did, but they got it. Okay. That was example 3. We'll begin next time with translations, but let me give you a few homework examples. Do any of the odds 5 through 17. And I think we'll stop there. 5 through 17. That's periods and amplitudes. Amplitudes and periods. All right, good deal, folks. Okay, you have everybody got the test, right? Did anyone not get the test? Okay, it's the people not here that don't have it. Okay, so thanks for being here. We'll move from there. Second? Yeah, I will be in just a minute. Let me get this shut down here.
I'll meet you. I gotta go.
Okay, all righty.